Hello and good afternoon, CSI258 Section 847 students for the second 8-week term of the spring 2015 semester at Anne Arundel Community College. This afternoon's Packet Tracer tutorial is going to be on Packet Tracer Activity 9.2.3.14, and this is the Troubleshooting Enterprise Networks 3 Packet Tracer activity. And I want to say right off the bat that this is definitely a difficult one, and one that I was a little disappointed with, and we're going to get to sort of the final step where it really isn't sort of I would say it's not really a troubleshooting issue, right? It's not something that's wrong. It's something that you could obviously change, but we'll talk about that when we scoot on here. So let's go ahead and start out. We've got our addressing table, as you can see at the top, and the background activity, the background of the activity is that we're going to be using all of our skills. We're going to take a look at Ether channel, port security, routing, DHCP, frame relay, PPP. So let's go ahead and jump in. So R1 is the DHCP server for the R1 LAN. Well, typically when we follow along here, they're kind of giving us clues as to what may be wrong sort of along the path here. So when they say that it's the DHCP server, let's go ahead and take a look at router 1 and let's see what that DHCP configuration looks like. So I transition from user exec to privilege exec with the enable command, and then we do a show run, and here's what we come upon. You can see here the IP DHCP pool. The name of the pool is access. We have our network statement, which details the network for which we're going to be providing, or within this range, we're going to be providing IP addresses. And then we have our default router statement, right? So if we were to take a look here, this is router 1. If we're giving DHCP addresses out, you can see that it ends in .10.10. Well, let's take a look at our addressing table over here and let's see. So the gig 00 interface, which is the interface on the R1 LAN, is 192.168.10.1. So we clearly have an issue here. So our default router statement looks like it could be wrong. Let's go ahead and do a show IP DHCP binding and see if we've given any addresses out yet. And it appears that we have given an address out. It looks like we've given out 192.168.10.3. And so the only other device on that LAN segment is switch 1. Well, let's investigate that. Let's go ahead and pull up switch 1 here. And let's take a look and see. And we don't have to go far, right? So you can see right away we've got the facility, which is DHCP, Dynamic Host Configuration Protocol. It is the level 6 severity, right? Informational, not notification. And then we've got the mnemonic, which is address assigned. So it means we've got an address assignment here. And interface VLAN 10 assigned DHCP address 192.168.10.3. It gives us the mask, and that is the host name for our switch. So if I were to go into privilege exec with the enable command and type show run, and we want to scoot down to interface VLAN 10, the SVI for VLAN 10, you can see that we're using IP address DHCP. And so this is how we're pulling our address. Now, a couple quick things here. Typically, what have we been doing all throughout the semester with DHCP? Well, if you're thinking that there's no IP DHCP excluded statement here, right? Where is that statement? We're not excluding anything, and so we're giving addresses out that are in very close to the addresses that we have assigned, right? So this is .1. We're giving out .3 here. .2 I don't believe is used, so it jumped to .3. So we don't have that statement here. Let's go ahead and add that in, and let's see if ultimately what happens, if it gives us any points at all. It may or may not, But best practice, right? It's a good best practice to exclude addresses in the range that you're going to be possibly statically assigning, right? So let's clear our screen here, and we'll come back. So the first thing that we're going to do is go into global config mode. I'm going to say IP DHCP exclude addresses, and we're going to, or excluded address 192.168.10.1 is going to be my first address, and then the high address is going to be 192.168.10, and we'll go ahead and run it up to .10, because typically we keep those first 10 addresses on reserve because we're going to be using them for the default gateway, maybe some other purposes, but we want the assignments to be outside those first 10. So I'm going to go ahead and hit enter. Now you'll notice this is not going to affect switch 1 because switch 1 already has a lease. If I do a show IP interface brief, you're going to see that switch 1 already has a lease on the 192.168.10.3. So what I'm going to do right out of the gate is I'm going to reload switch 1. And let's see if that DHCP excluded address range is going to be observed and followed here by switch 1. So we'll go to privilege exec mode. I'll say show IP interface brief, and it says DHCP, and oh, I'm sorry, so we've got spanning tree. We're waiting for spanning tree to converge here, so we can jump back over here. You can see that the interface did go down, and we don't want that. Let's do Control C there. So I'm going to say show IP DHCP bindings. Now you can see the binding still shows .3. Let's see what address did it pull. Did it pull a different address? Hasn't pulled its address yet. And it should grab 11 or 12. Let's see here. And it looks like it's, aha, so there we go. So 11 has been grabbed, but that's a different MAC. So let's check and see, did PC1 successfully get its IP? We had a different MAC address there. All right, so it looks like PC1 grabbed the 192.168.10.11, so it did respect and recognize that we had put in that IP DHCP excluded address range, and it picked the first address outside that range. So it went with .11. And let me stretch this out here because I know we're going to be doing some connectivity testing shortly. So we're good on PC1. Let's go back to switch 1 and let's see if it was just not being patient enough, which is usually the case. And it doesn't look like it. Let's go, whoops, conf t int VLAN 10. I'm going to say shut and no shut. Let's bring it, take it down and bring it up here and see if we get an address. So no, it's down and down. Let me check. So I know why it might be down. So why would the VLAN possibly be down? Well, let's take a look here. We've got a couple other things that are going on. So it says port security is configured to only allow PC1 to access switch 1's FA03 interface. So maybe it's possible that, let's scroll up here, what's the status of FA03? Now, interestingly enough, it says that it's up, right? And Fast Ethernet 04 says that it is down. So let's do a do show run here. All right, so FA03 says that it's up. So if I go into interface FA03 and say shut, we would expect that since this is labeled FA03, that these lights are going to go red, right? Because I'm shutting it down. So there we go, right? Excuse me. So FA03 is shut down. We're going to say no shut, and then we're going to talk about this for a second. So what has happened here is, if you look, FA03 was up. However, is it an access port? Is it in VLAN 10? No. In fact, if I were to say do show VLAN brief, do we have any ports that are in the up state in VLAN 10? We do not. Because remember, FA04 is not in the up state. So with no ports in the VLAN in an up state, what's the result? Is that VLAN 10 is going to be down. So when I say do show IP interface brief, it's going to be up down, right? So the line protocol, or the status is up, but the line protocol is down because we do not have an interface that is in an up status that is in VLAN 10. We have one configured, but that's FA04, which you can clearly see here is down. So that is not, that is not going to bring VLAN 10's line protocol into an up status. So let's resolve that issue right now. So let's say do show run, right? You can see we've got nothing on FA03. So I'm going to go into interface FA03 here, and we're going to say, well, first let's do a do show switch port, or do show, yeah, switch port FA03. Yeah, this command drives me crazy. So show interface FA03 switch port, sorry. All right, so let's see what mode this is in right now. So the operational mode is static access, right? The administrative mode dynamic auto, it's a port, trunk port by default. And it's interesting, it says static access, although it doesn't say, when we do show run here, it doesn't say switch port mode access. So this is extremely misleading, because if it was in the access mode, it would typically say access. So we're going to say switch port, first get into global config, and then go into interface FA03, where I'm going to say switch port mode access, right? So if I say do show run now, it says switch port mode access. Let's do a do show interface FA03 switch port. And let's see if it says the same thing here. You see that? So it still says static access. So there was another activity, and I believe it was all the way back in either 157 or I think it was 158 actually, where it was something similar, where it said that it was a static access port. However, it had never been configured as static access. So now the administrative mode is also static access, and the operational mode is static access. So we've got the switch port mode access. Now we're going to say switch port access VLAN 10. Now we should see a couple things here, and there it is right there. Line protocol on VLAN 10 has changed state to up. So now when I say do show VLAN brief, you can see we have 2 ports in VLAN 10. FA04 we can ignore, right? Because that was kind of, you know, they were baiting you with FA04, hoping you would see FA04's configuration and think, oh, FA03 is configured properly, maybe looking past the interface. Now, if I were to say do show IP interface brief, and we go to the bottom here, now you can see VLAN 10 is in an up state, right? So it looks like we are unassigned on our IP. We're going to give it some time here because it took the PC about 30 seconds to pull its IP. Let's come back over to the router here, and let's see what kind of bindings do we have. So it still shows that binding for .3, right? Because that's initially what the switch grabbed. So we're going to give the switch a couple seconds here to grab its address. So back over here, if I were to say do show run, there's FA03. So we've got some tasks outstanding still. It says that port security is configured to only allow PC1 to access switch 1's FA03 interface. So let's say switch port security. To activate port security, we have to have that command on, right? Now we're going to say switch port security MAC address sticky, because it says port security is configured to allow. Actually, it doesn't say to keep it in the config, but let's see. I think FA04 had that, so we may. I keep cutting off right there at FA04. So it did have the sticky. So we're going to go ahead and go with sticky, although it's possible they're looking for it to be hard-coded. So let's do sticky and see what happens here. So here's the key, right? Only PC1 is allowed to access that interface. So by default, how many MAC addresses are allowed when you do the switch port security maximum? It's 1. So as long as the sticky works and it picks up the MAC, the default is 1, so we don't actually have to set that. In fact, if I set that, switch port security maximum, you can see I can go up to 132. If I say 1 and hit enter, and then type in do show run, does it say on FA03 switch port security maximum 1? It does not, because that is the default. And then finally, all violations should disable the interface. Well, it just so happens that switch port security violation, we've got our 3 choices here that we should be very familiar with: protect, restrict, and shut down, where protect is simply going to drop the traffic, not generate a message, and it's not going to shut the port down. We've got restrict, that is also going to drop the traffic, not going to shut the port down, and it's going to issue a message, right? And then the final is shutdown. Well, shutdown is actually, again, the default. So when I say switch port security violation shutdown and hit enter and then type do show run, let's look at FA03 again. Sure enough, it's not there. So with port security, the default settings that we've seen so far, maximum of 1 MAC address, and the violation mode of shutdown, even if you set those are not going to show up. All right, so let's say do show IP interface brief. Let's see if we've snagged an IP address. It does not appear that we've got an IP address here. We should have picked one up. All right, we'll mess around with that a little bit, see if we can get that sorted out. So let's do a do show run. Let me make sure IP address DHCP, and I want to try to force it. So we'll go int VLAN 10, and I'm going to say no IP address DHCP, and then I'm going to say IP address DHCP to see if I can force it to query the router to send its discover and its request to try to get its IP address from router 1. So do show IP interface brief, and I may reload this guy one more time since they reload pretty quick. All right. Okay, so that takes care of the port security configurations. So let's, while we're here dealing with switch 2, 3, and 4. So we're going to take a look at switch 2, 3, and 4. So you can see we have channel group 2 on the left and channel group 3 on the right. So if I pull up switch 3 here, let's first take a look at switch 3. And we're going to say show ether channel summary. Now, this is very interesting. It says link aggregation using ether channel, but it doesn't specify PAGP or LACP, but it does say ether channel. And all the exercises we've done up to this point have been very clear, telling you you're either using PAGP or you're using LACP. In ether channel, remember, ether channel would be on. So if I were to take a look here and say show run on the first 4 ports, and this is interesting, right? So take a look here. Channel group 1 mode auto, and then channel group 2 mode auto. So channel group 1 is at the top, group 2 is here, and group 3 is here. So switch 3 appears to be properly configured. Now, it's set to auto, which is clearly the PAGP setting, not the ether channel setting, right? So remember, if I were to say, go into global config and say interface, FA will do 05 because it's not being used, and say channel group, we'll say 4 mode question mark, take a look. enable Ether channel only. And over here it says link aggregation using Ether channel is configured. So if you were to look at this and read this as I read it, it would look like, well, we've got to gut this entire configuration here because it's in auto mode, right? Which is a very reasonable thought to have. But let's take a look at the other switches. So let's look at switch 2 and see how switch 2 is configured. And here's where it's going to become even a little more cloudy. So when I say show run, take a look at channel group 1. What's the mode? Well, the mode is auto. If we go back to switch 3, what does the auto setting dictate? That you're only going to enable PAG-P if a PAG-P device is detected. Because remember, the two PAG-P settings are auto and desirable. Auto meaning that it's a passive, right? And I use that lightly because for LACP it is actually called passive, but auto is exactly that. It is not going to take the initiative to try to establish a PAG-P Ether channel configuration. It's going to wait and listen for the speaker at the other end who would need to be desirable to try to initiate that PAG-P connection. And so in order to show you that, I've got two switches, these two 2950s I have here. I've done some demos on these before. So let's go ahead and let's do that. Let's set both sides to auto and see what happens. So I'm going to go into global config. I'm going to say interface range FA0 1 to 8. And I'm going to say channel group 1 mode auto. Right? So we've just put all of those into auto mode. And I'm also going to say, I'll throw in here the, well, actually, we'll just leave channel protocol off. So I'm going to go ahead and set that to auto. I'm going to go to interface PO1 switch port mode trunk. Right? So if I were to say do show Ether channel summary, we have all standalone, all 8 interfaces are in standalone mode. Well, let's go to the other side, switch 2, and let's do the exact same thing. So we'll go to global config. I'm going to say interface range FA0 1 to 8, and we're going to say channel group 1 mode auto. Now, from what we're seeing in Packet Tracer, I should have no problem whatsoever right here with these forming interface PO1, switch port mode trunk, right? These should form an Ether channel, a PAG-P Ether channel right away. Because what Packet Tracer, and there you go, you see the interface is going up, so we'll say do show Ether channel summary. And what's the problem? Exactly. They are all in a standalone state. So let's go back and double check. Did anything change over here on switch 1? No. These are not bundled, and in fact you can see right here the capital S again stands for layer 2 and the D stands for down. And it's down because these are all in a non-bundled standalone state. Because right now it's sort of a standoff. Both sides are simply listening to see, hey, does anybody want to do configure or be in a PAG-P Ether channel with me? And that's it. But they're not actively trying to initiate and make that Ether channel happen. So it's an unfortunate setup over here where this, and there was another activity, like I said, I think it was in 158, that was like this, where it had settings that were impossible to have. So this setting that we have here, auto, let's check switch 4 and let's see if all the way around have they set PAG-P Ether channels all the way around to be auto. So we'll say show run, and sure enough, both switch, or I should say every switch 2, 3, and 4. And if you do the show Ether channel summary here, it says everything is okay. But we know better than that. We know that if you have auto and auto, it is not going to form a PAGP ether channel. And so let's prove that here. So I'm going to go ahead and say interface range FA01 to 8, and we're going to say no channel group 1 mode auto. And we'll spell auto correctly there. All right, so I've pulled the channel group 1 mode auto off of all those interfaces. So now let's come back and say channel group 1 mode desirable, right? Because one side of the PAGP ether channel is going to have to be desirable in order for the ether channel to form. So I'm going to hit enter. You're going to see we initially go to a down state. Let me see if I can do show ether channel summary real quick. And take a look at that. As soon as one side is set to desirable, the other side, switch 1 in this case, can be auto. And let's see what it shows over here. And there you have it, right? So again, it's an unfortunate configuration here between these three switches because this configuration would not work. This will not work. You cannot have auto on both sides of a PAGP ether channel. And again, it's even further confusing here saying link aggregation using ether channel. Because the misleading part is if you were to look at this and say, oh, well, these are all auto, it can't be all auto all the way around. So then they must be talking about just using on. So then you would tear this entire configuration down, push it into on mode, which I did off camera, and it doesn't. That's not what it's looking for, right? And it's quite interesting what it is looking for. So let's take a look here. We're on switch 4, and you can see we have channel group 2 and channel group 3. So 01 is channel group 3. I'm sorry, FA01 and FA02 are in channel group 3, right? And FA03 and FA04 are in channel group 2. However, it was typically that these were matched, right? So it looks like these could possibly be backwards. So let's go ahead and go into global config, and I'm going to go into interface FA01, and I'm going to say shut. And you'll notice that when I type shut, that it takes the link down that is supposedly supposed to be in the channel group 2. So let's say no shut, again bringing back up that link in channel group 2. So let's do a do show run again. What channel group is FA01 and FA02? Which channel group are they in? Well, they're in channel group 3, not 2. They're supposed to be in 2. So let's do this same little experiment. Let's go into interface FA03. Whoops, say interface FA03 and say shut. And you can clearly see that FA03, which is listed in this config as being in channel group 2, is not. It's in channel group 3. And so this was an extremely difficult one to run down and figure out that the channel group 2 and 3 are actually backwards. So how do we resolve this? Well, we just need to flip it, right? And again, we're going to flip it, and I'm actually going to go ahead and put it, leave it in auto. While I was troubleshooting this earlier, it was I tried desirable, and it did not like the desirable setting. It's actually looking for it to say auto. So let's go ahead and say interface range FA01 to 2. We're going to say no channel group, no channel group 3 mode auto, because those are listed for channel group 3 right now. What we are going to say is channel group 2, sorry about that, channel group 2 mode, and let me put desirable in here and see if it likes that. Pushed them to up, and it did. Okay, good. Yeah, earlier, and maybe it was I was troubleshooting, had so many things that were changed the configuration that it didn't like it. So, but it should take that. All right, so now we've got that set up properly with the desirable keyword. So now if I say do show run, all right, we've got our channel group 2. Now we need to change 3 and 4. So let's say interface range FA 03 to 4, And we're going to go ahead and say no channel group. So no channel group 2, mode auto. And now we're going to say channel group 3, mode desirable. So we're going to change that to desirable. All right. And so as you can see, it awarded us the point, so it did take that. That was okay. But again, that is extremely misleading. If I say do show ether channel summary, that it actually showed that we were in an up bundled state, and these were all in the port channels when everything was auto, right? That would have not been possible. All right, so we've flipped these over to desirable. And that should, let's see here, we've got the links are flashing. Link aggregation using ether channel on switches 2, 3, and 4. Did I leave, let me make sure I didn't leave any interfaces shut down. There we go. So interface, and so let's just say no shut. There we go. We'll bring FA03 up. So do show ether channel summary. All right, so now it shows both of our ether channels. They've been properly configured, and they are both in the port channel. And again, interestingly enough, when I solved this initially, I left everything in auto because, again, I had put desirable in, and it didn't take. But that may have been because I was changing so many things around. But it's taking desirable, and that's what it should be. And it should be that. Same thing here, channel group 1 between switch 3 and switch 2, these cannot be auto on both sides. So again, if we look on switch 3 and I say show run, you can see that everything for channel group 1 is auto. And on switch 2, everything is auto, right? So I'm even going to go ahead and I'm going to tweak this. I'm going to fix switch 2 because this is not sitting well with me right now that they've got this completely misconfigured, even though if I say do show ether channel summary, look at that. It shows that everything is bundled, everything's up, and we're good to go. But we know that it is not. And I'm not sure that there are any points awarded for this. So what we're going to do here is we're going to say interface range FA channel group 1 is 1 and 2, FA0 1 to 2, and I'm going to say no channel group 1 mode auto. Whoops, and it took it even though it was misspelled. So now I'm going to come back and I'm going to say channel group 1 mode desirable. And you'll notice it didn't award us any points, even though if I was troubleshooting this, that's a definite concern, right? Okay, so now we'll say, and actually spanning tree is doing its thing. So if I say do show ether channel summary, you can see that it shows that everything is bundled and we're good, right? And group 1, group 3, okay, so we're good there. All right, so at this point, we are good to go from my perspective on the ether channel configuration here. And again, remember, you cannot have auto on both sides and have PAG-P successfully bundle the ports into the ether channel. As we saw right over here, it won't work, right? So on these two 2950 switches right here, we've got auto on switch 1 side, but over on the switch 2 side, what do we have to have? You got to have desirable, right? And so you can see right here that the first 8 ports, and again, I've just got 8 connections running between these guys for ether channel demonstration purposes, that one side's got to be desirable. It's the same thing with LACP, right? If I have active and passive, I can't have passive on both sides. The ether channel will never form, right? One of the sides has to initiate and say, hey, let's form an LACP ether channel. I'm set up to be active. And the passive side says, yeah, okay, cool, because I'm passive and I can do LACP, so let's do that. But the passive side's not going to initiate that configuration. And I like this picture that we have up here. Looks much better, right? Much, much better. We've got we're blocking here, right, on switch 4, but we've got all green everywhere else. So spanning tree is doing its thing and it's forwarding traffic, and again blocking this link to prevent a loop in our topology. Okay, so that's enough time on the switching side, and I feel much better about this configuration than I did the configuration that they left us with. So now on to the routing. So all routers are configured with OSPF process ID 1 and no routing. This should be your key right here. No routing updates should be sent across the interfaces that do not have routers connected. So router 3, this interface right here, which I'm assuming is gig 01, that has got to be a passive interface. This is going to the internet, so that's not even going to be, should not even have be advertised in OSPF. The gig 01 should be passive, and then gig 00 should be passive. So let's dive in here on router 1. We'll just go around in numerical order. So I'll go from user exec to privilege exec, and we'll just say show run. And let's take a look at the OSPF config. On router 1, gig 00, passive interface, gig 00. Now, as I'm sitting here looking at this, this certainly caught my attention. Default information originate. So if the internet is here, right, our, sort of our outside interface, or our connection to the world, on router 2, gig 00 should probably be the default route to which all of these routers are going to be sending traffic for a default gateway. So let's look down here. It says R2 is configured with a default route pointing to the ISP and redistributes the default route. So it's R2, and that is the way it should be, but that is not what's happening here. So even though that's the next step, let's take care of this right now, because router 1 should not be, router OSPF 1, router 1 should not be advertising with a default route with the default information originate command. In fact, if you say do show run, is there even a default route configured? And I could say actually show IP route. Yeah, so we don't even have a default route configured on router 1, so to have it to distribute it, right? So that's clearly a bad statement there on router 1. So let's go back, do show run. Want to check the OSPF one more time. So I like to take a look. So passive interface looks good. Log adjacency changes. That's great. So the two network statements for router 1, if we look at the addressing table, we should have 2/30s that router 1 is going to be running the OSPF process on, 10.110 and 10.330, both /30s, right? So it's going to be .3 at the end here. So there's the 10.110, the 10.330. We're in area 0. We're good there. And we're passive interfacing that gig 00, and that is the network, the subnet for that. So we're good there. So router 1 looks good. So let's go ahead and clear our screen here for router 1 and go ahead and type in, and let's scoot up, because again we're taking a look at making sure the router process ID is 1 and that we've got passive interface properly assigned. So let's go to the CLI here, go to privilege exec, we'll say show run, and as we scroll down, all right, so here we go. So log adjacency changes, okay, that's good. Passive interface gig 01, again, spot on, right? The three networks, if we look at the addressing table, 10.110, 10.220 /30s, we're good there. And the network 192.168.20, it's a /24, so we're good there. So everything looks good here. What's the one thing we wanted to catch, right? So R2 is configured with the default route, as you can see right here. And unlike the other troubleshooting exercise, this is being sent out the correct interface, gig 00. So we're happy with the default route. And so let's go ahead and say configure terminal to get into global config mode. We'll say router OSPF 1, and it's from router 2 that we want to originate that default route, because router 2 has the connection to the internet. So we've added that statement in there, so that looks good. So everything looks good OSPF-wise so far. Let's scroll down here to, whoops, to router 3. And let's see what router 3 has in its OSPF config. All right, so we've got log adjacency changes, and then this should catch your attention immediately. So passive interface default. What this setting does is it sets every interface on this router into passive mode, which means it's not going to try to establish an adjacency with either router 1 or router 2, right? Let's check our subnets here, or our network statements, to make sure the subnets are correct. 10.220.10.330, good. 192.168.30, good. Yep, that's good. So we're good there, but this is a problem. It shouldn't be passive interface default. We should only be passive interfacing gig 01, which is the interface that goes to our LAN segment, right? 192.168.30. Okay, so let's go ahead and go into global config, and we're going to say router OSPF 1. I'm going to say no passive interface default, and I anticipate that we might have an adjacency pop up here, although we've got some WAN work to do. And I'm going to say passive interface gigabit Ethernet 01, and there we go. So our adjacency between router 1 and 3 has come up, and that's good news, because that also tells us that the serial link, which if you look down in the WAN technology section here, is using PAP. This tells me that that is properly configured. If PAP was not properly configured, we would never get from loading to full. In fact, we would never get anywhere, right? So, and then I'm going to passive interface gig 01 do show run, because that interface should be in a passive state. Gig 01, passive, good, we're good there. So if I say do show IP OSPF neighbors, you can see that router 3 only has a single neighbor, and it's router 1. And that kind of leads us to believe that while the WAN connection, the serial link between 1 and 3 is okay, chances are we're going to run into some issues with something going on between router 2 and router 3. But let's go ahead and keep going in order here and keep driving on. So all of the OSPF looks good, passive interfaces look good. R2 is configured with the default route, and it's originating that route. In fact, well, actually, we don't have an adjacency between 2 and 3 yet. So let's move down to NAT is configured on R2. No untranslated addresses are permitted across the internet. So let's take a look at the NAT config, because there may be something wrong with the NAT config. So if I were to say do show run, and where are we at here? So, and actually, it'd be a little easier if I were to say do show IP NAT translations. We've got none. What about do show IP NAT stats? Because this gives us a better feel here. So my outside interface, right, is gig 00, so that's correct. And then what about my inside interfaces? 01, serial 000, and serial 001. So this looks good, right? NAT actually looks good here, but I want to see, just because we have the IP NAT inside and outside statements correct doesn't mean that we have the larger issues that can occur, which are tying the access list, making sure we have the right kind of NAT, tying the access list to the NAT. So IP NAT inside source list NAT, so we better have an ACL that is named NAT, and it's using the interface, right? Again, it's getting its interface, is it DHCP on router 2? No, okay, it's hard-coded. But it's just got the interface in here, and this is okay to use. And the use case for this is probably when we have a static IP, it's more likely that you would put the IP in here, but this is okay, right? If you were doing DHCP and that IP might change, you definitely want to refer to the interface. And then we have the overload keyword indicating that we are doing dynamic NAT, right? I'm sorry, NAT overload, which is PAT. Okay, so we're doing NAT overload, which is called PAT, port address translation. So let's go down and let's see if we have an access list. And we do IP access list standard NAT. That is correct. And it is permitting everything on the 10 dot as well as everything in the 192.168/16. And that is correct. So interestingly enough, and this has me concerned because they've got it listed over there, but everything looks good. So we'll go ahead and we'll move on with the assumption that that is correct, that that everything is correct there. All right, so the serial link, let's go down to the WAN technologies. The serial link between R1 and R2 uses frame relay. So let's pull up R1, and you can see R1 looks like it has 2 neighbors. So what this tells me is I've got a neighbor relationship, and don't be confused here. Remember that how does OSPF pick out its router ID, right? Well, one, if it's configured, that's going to be the router ID. Under the router OSPF configuration section, that's where that would be configured. If it's not configured, it's going to take the highest numbered loopback. And remember, the highest numbered loopback doesn't mean like loopback 10, 20, 30, 40, 50. It means the loopback with the highest IP address. Well, there were no loopbacks on router 2. So if it's not configured under the OSPF section, if there's not a loopback that's in an up state that has an IP address assigned to it, it's going to pick the highest numbered up interface. So let's pull up router 2 and say do show IP interface brief. So what is the highest numbered, highest IP address on any of these interfaces? It's on gig 00, and therefore that is the router ID, right? So this could be a little misleading because typically what do we see? 2.2.2.2 for router 2 or 3.3.3.3 for router 3. Well, we don't have loopbacks configured, we don't have the router ID statement configured, but what we do have are IP addresses on interfaces that are in an up status, right? Okay, so it shows here that this is router 2, and it shows the address of the neighbor 10.1.1.2, so we know that it's router 2 out that serial 000 interface. And this may also be a little misleading. Now remember, we're doing frame relay out this interface, right? And it's set up for broadcast, so this is going to be, that's why we have the DR BDR election, where typically on a point-to-point interface that's not doing frame relay, you do not have your DR BDR election, right? Okay, so that looks good. Let me do a do show run, because if R1 and R2 have established that OSPF adjacency, show run. If they've established that adjacency, that means the configuration on serial 000 for both R1 and R2 is correct. And let's take a look. In-cap frame relay, we've got everything we need there is right. Let's take a look at R2. And shockingly, this also appears to not have anything wrong with it. So now let's go back here to the serial link between R2 and R3. And it says that uses HDLC. Well, how do we tell if R2 is using HDLC? Remember, HDLC is the default, so it would say nothing. And you can clearly see here the serial 001 link is set up for frame relay, and we know that that is not what it's supposed to be, so we're going to say no in-cap frame relay. You'll see that the interface changed the state to up. Let's take a look at router 3's serial 001 interface. It looks like it changed the state to up here too. Do show run, and everything looks good because I think we just saw, and that's what it looks like when it's using HDLC, because HDLC is the default, right? So now it looks like router 2 has an adjacency do show IP OSPF neighbor. All right, so that looks good there. And let's see, are we picking up that default route? So show IP route. We are. It's coming in as a redistributed, an external type 2. And you can see it right here. There's our default route. Does R3 see the default route? Do show IP route. and it does, so that's good. So the link between R2 and R3 was using the HDLC encapsulation. So now let's take a look at the serial link between R1 and R3. We already saw the adjacency come up. Let's just take a quick look to make sure that it's sending the right username and password. So PAP sent username is going to be R1, the password Cisco CCNA. If we scroll up here, we should say an entry for R3, password CCNA, Cisco CCNA. So it looks good there. And again, the adjacency would not have established if we didn't have this correct. So then we've got the corresponding username R1, password Cisco CCNA, and NCAP PPP, PPP auth PAP, and then R3 password Cisco CCNA. So that also looks correct. So if we look down the list here, we've got port security. We've taken care of the port security on FA03. We took care of the DHCP settings that we had. We took care of the Ether channel, and this would have been extremely confusing and difficult to accomplish. Because again, I mean, just from the get-go here, it doesn't say, I don't see anywhere else in here where it says PAGP, and maybe it does. It doesn't. It actually just continues to say Ether channel throughout the document, and maybe I'm missing it, but I don't see PAGP in here. So that would have been extremely confusing. So let's go ahead and check back on switch 1 here, and let's say show IP interface brief. Let's see, did it ever pick up an IP? It doesn't look like it did. Let's go back over here and say show IP DHCP IP DHCP bindings. So it still shows that third binding here. So here, let me do this real quick. So let's make sure we write mem. I'm just going to reload switch 1 real quick and see if I can force it to pick up a different IP address for VLAN 10. So press return to get started and show IP interface brief. Might not have it yet, so spanning tree is still converging. Alright, change state up to down, so show IP DHCP bindings. Still shows that 3. Can we even ping that? So 192.168.10.3. Yeah, because switch 1 is not picking that address up. Yeah, so let's cruise back to switch 1 here. And it doesn't want to cooperate, at least on VLAN 10. So that's okay though, because I don't think that that's why we're short here on the point. So now I'm going to get to the issue that took me a substantial amount of time to run down here, and that is on switch 3, right? If I do a show run, you'll notice that we've got gig 01 and gig 02, and this is labeled gig 01. So on switch 3, if I were to go into global config and go into int gig 01 and say shut, right? So it is gig 01 between switch 3 and router 3. They're both using their gig 01 interfaces, right? So I'll bring that back to an up state. And then what we're going to say, let's come to PC2 here. And let me see if PC2 has connectivity out to the internet. So I'm going to say ping 209.165.200.226. And we should have some failures here. Spanning tree still doing its thing. So spanning tree is back up now. So let's see what happens. So my first request times out. And then we've got connectivity, right? So I can actually successfully ping from PC2 out to the internet, right? So is there anything wrong with the way that this is configured right now? So let's take a look again at switch 3, do show run on gig 01. Is anything wrong here? If I say do show interface gig 01 switch port, let's see, what is the operational mode? It says static access. Is there anything wrong with that being a static access port? And the answer is no, not in this configuration it's not. Because again, if I go to switch 3 and I say do show VLAN brief, so we have some other VLANs configured, but none of those VLANs are being used right now, right? So what, let's see, what port is PC1 in? Let's turn PC2. So if I take a look at the physical, we turn it off. Well, let me turn the power off. All right, so we'll bring it back up. And it's probably not going to... Oh, here, let's just do... Sorry about that. On switch 4, we'll say show IP interface brief. And it's got to be 5, right? Fast Ethernet 05. Because 1, 2, 3, and 4 are being used here. And 5 is the only other interface that is up. So let's confirm it. So go to global config, interface FA05, shut. Okay, link went red, so it's definitely FA05. So we'll say no shut, allow it to come back up. So again, sorry about that, let's bring this back here into the fold. So again, on switch 3, so sure, there's a VLAN 11 and a VLAN 30, but these are not being used. There are no ports assigned. So right now, let's come over to switch 4 and say do show VLAN brief. Everything is in the default VLAN, which means that this PC2, is in the default VLAN. So if we only have, and let's check switch 2. And again, they show you here this FA05 up on switch 2, but the PC is not connected to switch 2. If the PC were connected to switch 2, and it was an FA05, and it was in VLAN 11, then we would have an issue. But right now, we don't have an issue because this is okay as an access port, because what access or what VLAN is it in? It's in VLAN 1. So PC2 is in VLAN 1. Our link to the router is in VLAN 1, which means our default gateway, if I pull PC2 up, what's our default gateway on PC2? Sorry about that. Should be 192.168.30.1. That is the interface on router 3. So there's nothing to troubleshoot here. This is, for this configuration, that is correct. However, as I was looking around, you know, like I said, I was kind of doing this offline initially because I got to this point and it wasn't clear what the next fault condition was going to be. And that's when I noticed they have this VLAN 11 here on FA05, but up here, and then down here, I'm sorry, on switch 3, they show VLAN 11 and VLAN 30, but again, no ports, right? So how have we typically done this the entire semester when we have multiple switches and we could have multiple VLANs with PCs that could be in multiple VLANs? If you're thinking router on a stick, you're absolutely correct. And what do we need on the switch? Now, again, there are no sub-interfaces here, right? The interface, or the IP, is applied to the physical interface. There is no gigabit Ethernet 0/1.11 and 0/1.1 and .30, right? because again, I don't see a fault here, right? I do not see something to troubleshoot here. However, getting lucky and trying, Cisco thinking as to what is it that they might be looking for. So the first thing I did was I went into interface, gigabit Ethernet 01, and I said switch port mode trunk. And I flipped it to a trunk port, and you notice the interface went up and down, but more importantly, we immediately received the points. So again, to recap, because this was a tough one, and this was actually, again, not really a fault. It was not something that we needed to troubleshoot. The PC's in VLAN 1. The router port is connected to the switch in VLAN 1. So we're not doing inter VLAN routing because we don't have other PCs with which we're trying to route, right? That are in other VLANs. We have that single PC and that is it. So unless I'm missing something, I don't see the fault there. But however, changing it to a trunk port resolves the issue. Okay, so we've got that right. We took care of the encapsulation. Our passive interfaces are correct. We've got our default originate statement that was correct. The PC can still, so let me double check here. So can we go from PC2 back out to the internet? Is it still working? It still works, right? So can I ping over to 192.168.20.254? Does that work? So the first one times out, but then we've got connectivity. So PC2 appears to have full connectivity. What about PC1 here? So we'll close that down. Can I ping PC2? PC2 is 192.168.30.10. So let me try to ping PC2 here on the other side. First request is going to time out. All right, so the second request times out. So I can't get from PC1 over to PC2. So it looks like there might be another issue. So can I get out to the internet? Ping 209.165.200.226. So can PC1 make its way out to the internet? So we've got a timeout, a timeout. It's not looking good. So it doesn't appear that PC1 can get to the internet. So PC2 can't get to PC1. Or I should say PC1 can't get to 2, and PC1 can't get to the internet. So is there something wrong on this side? Let's see how far we can get. So trace RT. For trace route, let's go to 209.165.200. What do we say? 226. Let's see where I can trace to. It doesn't look like I can go anywhere. All right, so let's take a look at our config here on PC1. So we'll go ahead and kill that. So let's pull this up. So what default gateway did we get? You'll notice it picked up the incorrect default gateway, right? So if I click it back to static and then flip it to DHCP, let's see if we get the correct default gateway. We don't. We're picking up an APIPA address. So let's roll back here to router 1 and let's see what we've got going on. So we'll say show run, and we actually changed that, and I don't think I rebooted router 1. Huh. All right. So that's definitely wrong. So let's say IP DHCP pool access. We're going to say no default router 192.168.10.10, and I'm going to say default router 192.168.10.1. Right? Now you'll notice it's interesting. It gave us the points. And maybe I did. I have to watch this back as rewatch this, but I don't think I rebooted this, and I would have saved the config. Maybe it was the messing around with the IPDH, maybe changing the IP DHCP excluded, because that is still, yeah, so I could not have rebooted the router, or that would have been wiped out unless I did a write mem. So maybe I didn't enter that in. I'm positive that I had, though. All right, so now let's do a show IP DHCP bindings. Okay, so the switch is still not cooperating. All right, so but we're looking good here on the PC, I would think. Let's go back. Let's go static, and then is he going to pick up an address here? It should be a 192.168.10. Yeah, and the APIPA has failed. Let me check. Let's look at the switch real quick. Maybe that DHCP excluded. It doesn't like that. So let's say show run, and let's look at. All right, so it's got the right MAC address in there, right? So that's the MAC address, and we're in VLAN 10. Show VLAN brief. Let's double check. Yep, FA03 and 04. So show run are in VLAN 10. So that is correct. VLAN 10 is IPDHCP VLAN 10. So let me pull out, let me do this, because it may be something. Let's do a write mem here, and I'm going to reload this, the router, and let's see, even though we've got the points, let's see if the DHCP clears and that it's not, that it's holding on to that binding that's, oh boy. So it took us all the way back. Even though I did a write mem, it completely wiped the config. So, all right. So we had the 60 out of 60. Maybe that IP DHCP excluded had something to do with it. We did see all the steps. And again, the two toughest ones were the Ether channel here, just to recap. And then again, I don't see this as a fault, right? There's nothing wrong with that being an access point or an access port if we're not doing inter VLAN routing and trying to set this up as a router on a stick. There's nothing wrong with that, right? So this wraps up Packet Tracer tutorial 9.2.3.14, troubleshooting enterprise networks number 3, and the next one we're going to be doing is the IPv6 activity. All right, thank you for watching, and hopefully this has cleared up any confusion you might have had and solved any sticking points where you may have been caught up not sure where to go. Thanks for watching.